So we've been solving inequalities. Now we're going to talk about compound inequalities. Again, things that should be review for you, but these are a little bit more complicated. It might take a little bit more refreshing than what we've done so far. Okay, so what we want to be able to do by the end of the class, we want to be able to solve and graph compound inequalities, which we'll take care of first, and then write some compound inequalities to model some real-world situations. Okay, some vocabulary for you first. And again, guys, your non-calculator part of your test should be a slam dunk, 100%. You guys just are not studying your vocabulary. Okay, that's one big problem. So make sure you're going back and taking a look at these vocabulary terms and you understand what the definitions are. But a compound inequality consists of two distinct inequalities joined by the word and the word or. These are the and or guys. Okay? Yeah. And if we're going to use an and compound inequality, then we want the solutions, we're going to show in our graph the solutions that satisfy both inequalities. It has to be both. Whereas, in contrast, if we're going to use an or compound inequality, then we want to make sure that we're graphing talking about the solutions that satisfy either one. Right? So, and implies both, or implies either. It doesn't matter which one the solutions would satisfy. Okay? All right. Where were we? Here we go. Now, if we're talking about and compound inequalities, when we read them, so if we have x is greater than 3 and x is less than 7, it's exactly how you want to read it. We are concerned with the real numbers that are greater than 3 and less than 7. If they're greater than 3 and less than 7, then the numbers that are going to be solutions are going to be what? Between. So like 4, 5, 6. Right? So the solution must be both greater than 3 and less than 7. Now if that's the case, and Rex just said it, between, if our solutions are going to be between 3 and 7, then we can rewrite an and inequality. It looks like this, where x is right in between two inequality signs. And so this means the same thing. 3 is less than x, which is less than 7. Okay? And so this shows us that we want all of this, we want to color in, when we graph this, we want to color in all the solutions that are between 3 and 7. Okay, so why the graph looks like that. And of course, open circles on 3 and 7, because we don't want to include 3 and 7. All right? Remember this stuff a little bit? Now, also, a little word, and it's in the below the box in your notes. If you're given a compound inequality, such as 5 is less than or equal to x, which is less than or equal to 10, okay, again, it can be, if we got less than or equal to, if we're talking about equal to, then that means that our solutions can be between 5 and 10 inclusive. Inclusive means that we're going to include 5 and 10. Okay, so you'll see it read, you'll see it written, you'll hear it as read as that. X is between 5 and 10 inclusive means that we're going to include 5 and 10. Okay, now, or. Inequalities with the word or. If x is less than 3 or x is greater than 7, then that means we'll take solutions that are less than 3 or greater than 7. And so the graph would look something like this. If we're going to shade in the solutions of this compound inequality, then we'll take these guys that are less than 3, or we'll take these guys, which are greater than 7. Okay? Very often, not all the time, and so I always kind of balk about saying this, but very often when you graph the solutions of an or compound inequality, they should look sort of like oars on a boat. Right? If you ever think about rowing, right? You've got oars out here. Yeah. Not always, but very often that'll be the case. Okay, but the graph should look something like that. Okay, all we've got to do is make sure that we're reading the inequalities correctly. Now, let's get to it. Write and graph the compound inequalities. Number one, all real numbers that are greater than -3 and less than 6. If we're concerned with all real numbers that are greater than -3, so that means all numbers, and x can represent all numbers, that are greater than -3, and all numbers that are less than 6, then you could write it like this. So x is greater than -3 and x is less than 6. But what we know is that also what we're talking about are the solutions are between -3 and 6. And so you could write it like this, right? Where x is between -3 and 6. That might even, I think that even makes it a little bit easier to graph. Right? If we're talking about all real numbers between -3 and 6, are we going to include -3 and 6? No. This is not inclusive. So we're going to open circle -3 and 6 and then shade in between them. Okay? So when you write your compound inequality, you can write it like this or like this. This is the preferable method. All right? What about this guy? All real numbers that are less than 1 or greater than or equal to 3. Write that compound inequality out and then try to graph it, and I'll give you about a 5. So, what did you come up with? All numbers that are less than 1, so x would have to be less than 1, or we'll take any numbers that are greater than or equal to 3. So it would look like that. Well, on your graph, we'll take any numbers that are less than 1, so open circle, less than 1, or greater than 3. So closed circle, greater than or equal to, closed circle, and to the right. And there's your oars on a boat, right? There are your oars on the boat. Okay? Any major issues or questions there? Okay. Now, if we're solving compound inequalities, and in particular when we're solving and compound inequalities, the problem sets up a little bit differently because of the way we can write our and inequalities. Okay? So for like number 3, -2 is less than x plus 3, which is less than or equal to 4. Well, if we wanted to, we could separate those two out, right? We could split these up. If I've got to solve, I've got to do some stuff to isolate the variable here. So it might make more sense to split these up and then bring them back together when we're done. Okay, don't do this. Don't write this down. Okay? I'm just going to show you why we do what we do. Well, if I split them up, I'm going to subtract 3 here, subtract 3 here. So I'm going to subtract 3 from both sides in the top one. Well, I'm also going to subtract 3 in the bottom one. So I'm going to do the same thing, even if I split them up. Right? So what we do is we say, well, it's ridiculous then to split them up if you're going to do the same thing. So instead of going through all of this, why don't we just keep it in this same format and just show that we're subtracting 3 from all 3 parts, if that makes any sense. Right? So this is still going to be 0. 3 minus 3 is still 0. So the middle part would still just be x. Then you have your less than sign here. -2 minus 3 is -5. and 4 minus 3 is 1, so we get less than or equal to 1. So we arrive at the same inequality, only we didn't have to separate them and bring them back together. We just kind of do it all at once. But whatever we do into the middle to isolate the x, we've got to do the same thing to the left and the right side. Okay? So we're going to do it instantaneously. And then we just graph it. Okay? Are we going to include negative 5? No. So open circle, negative 5, open or closed over 1. Yep. And then we want all real numbers between negative 5 and 1. And so our graph would look like that. Okay? Any major questions or issues there? Good. You try. Skills. Here we go. What'd you come up with? So the first thing we got to do is we got to isolate that x is to add the 3 away. Right? So that's get you your 0 there. You get 2x less than or equal to 13. 2x is greater than 8. Right? And then to isolate the x, you got to divide by 2. So that means you got to divide everything by 2. And so you're left with 4 is less than x is less than or equal to 13 over 2 is fine. When you divide by 2, the decimal's pretty enough. You can make it 6.5. It might be easier to graph that way. Either way is fine. So I'm going to put 0 over here just because I know that 4 and 6.5 are both on the right-hand side. Okay? And again, the compound inequality and tells you that we want solutions, we want values in between two different numbers. So in between 4 and 6.5. So open circle 4, closed circle 6.5. And we want those guys right there. Okay? Make sense? You get there? Awesome. Got another one. Try that guy. Did you come up with this? So add 16. And then divide by 3. Until you get 4 is less than or equal to x, which is less than 7. Okay? So 0, you're going to go here, 4 here, 7 here, just because I know 4 and 7 are on the right side of 0. Open and closed. Open or closed on 4? Close. Open or closed on 7? Open. And we want all numbers between 4 and 7. If you're not sure, then read the inequality with the variable first. X is greater than 4. So I want everybody greater than 4, and x is less than 7. So I want everybody greater than 4 and less than 7. That keeps you right in here, right inside the house there. Okay? Good. All right. Fractions. What if we introduce fractions? That's no problem for us because we clear our fractions. We don't add and subtract fractions. Right? We clear them. So we want to multiply through here by the least common denominator. And that denominator for the 7 is a 1. So the least common denominator is 4. So multiply by 4, multiply by 4, multiply by 4. Okay? When we do that, 4 times 1 is 4. Divided by 2 is 2. Now, in the middle, it's a little weird, but we have a 4 in the denominator and a 4 in the numerator, so I'm just going to divide them out. And left just 3x plus 4. And 7 times 4 is 28. And now, we're just right back to where we were on the last couple of problems. We're going to subtract 4. Okay, and then divide by 3. So you end up with negative 2/3 is less than or equal to x is less than 8. Okay? And then we're ready to go solve. And then we're ready to go graph. So 0's here, Negative 1 is here. 8 is probably out here. And we want a closed circle on 2/3, which is about right there. Open circle on 8. And then we're going to shade in between. Okay? Haven't done this yet, but it would be awfully nice if you guys would include that this number is supposed to be negative 2/3. That really should be in the graph. Just in case your tick mark for negative 1 runs into your dot for negative 2/3, and I can't tell what you're supposed to be showing. That would be nice. Okay? Questions? Cool. Now your turn. Try that guy. A little more complicated, but we'll figure it out. Clear the fraction. Multiply through by 5. Okay? Now, again, since this whole middle part has a denominator of 5, then we're going to end up with a 5 in the numerator and a 5 in the denominator. So those guys are going to divide out. Okay? So we're going to be left with negative 2x plus 8 in the middle. Now, on the left-hand side, we get negative 15. On the right-hand side, we get positive 15. Okay? Now, we're back to right where we were a couple of problems ago. Subtract 8, subtract 8. This is negative 23. This is 7. And then you got to divide everything by negative 2. And when you divide by a negative, you still have to switch the sign. This is basically 11.5 is now greater than, is now greater than x, which is now, 11.5 is greater than x, which is greater than or equal to negative 3.5. So you've got to flip the signs, which makes sense, right? If you're going to end up getting 11.5 on the left-hand side and negative 3.5 on the right-hand side, then x can't be greater than positive 11.5 and less than negative 3.5. If you really read the inequality the way it would have if you didn't flip the inequality signs, it wouldn't make any sense. This is the only way it makes any sense. Anyway, if you divide by a negative, we're still going to switch those signs. So we need a 0 here, negative 3 here, negative 4, and then maybe go 11 and 12 here. And then we need an open or closed circle on negative 3.5. Yeah, closed. Good. So right here, negative 3.5. And then open and closed on 11.5. Yeah, open, which is right here. And then we're going to shade in between. Okay? Piece of cake, right? Okay, got one more for you. What'd you come up with? Got to multiply everything through by 3. Okay, these 3's will divide out, leaving you with 15 is less than. X minus 1 is less than or equal to 18. Now we're going to add 1. Okay, and so we get 16 and 19. So now we want all real numbers between 16 and 19. No problem. Open, closed, shade, done. Right? Piece of cake. Questions? Okay. Just a couple of places that you might get stuck, and so be careful. All right. That's and compound inequalities. If we have or compound inequalities, then there's nothing really tricky or cute about these. You just simply solve the two inequalities separately, right? So we got t plus 5 is greater than 11, or negative 2t minus 10 is greater than or equal to 20. We'll just solve them separately. Subtract 5. Then add 10. Divide by -2. Remember, you got to flip your inequality sign. So, our compound inequality turns into t is greater than 6 or t is less than or equal to -15. What the heck does that all mean? Well, here's 6. Here's -15. And just graph them individually. T is greater than 6. Means we want an open circle on 6. And we want all real numbers greater than 6. We're going to go this way. T is less than or equal to 15. Closed circle this way. And there are your oars on a boat. Okay? Any major issues there? We got a couple of practice. So here's 10. Okay, how'd you do? Okay, we got to add 8 here. Divide by -4, which means switch the sign. That's right. Okay, and then subtract 7 here. Divide by 3. Don't have to worry about switching the sign there. So now we want all real numbers less than -5 or greater than 6. So we need -5 and 6. Okay? Henry, turn around. Open circle here. Open circle on 6 as well. We want greater than 6, less than -5. There are your oars on the boat. All right? Good? All right, got one more, and then we're going to talk about some story problems. All right. Whoops. Here we go. Work this guy out, and then we'll talk about the story problem next. It's a little on the tricky side. So we're going to subtract 3 from both sides. Divide by 4. 2 over 4, same thing as 1/2. Add 2. Divide by 5. And x is greater than 4, and this is an or. So I want all real numbers less than 1/2 or greater than 4. So 0 here, 1 here, 4 here. I'm going to open circle or closed on 1/2. Open. And we want less than 1/2, so we're going this way. And then open circle on 4. We want greater than, so we're going this way. Okay? And there are your oars on a boat. Okay? Questions there? All right. Story problem. Story problem. Guys, you can't run away from them. They're not going anywhere. The whole point in studying algebra is so that we can use algebra to model some real situations, right? And here's one. Your Algebra 1 teacher has given 3 tests. You want to earn a B in the class, so you must achieve a test average between 83 and 86 inclusive. What inclusive means? Okay, you have scored a 79, an 88, and an 82 on the 3 tests so far. What possible scores can you earn on the 4th and final test to earn a B? Okay? So here's what we know. We know that your average has to be between 83 and 86 inclusive. So that suggests an and compound inequality. So your average can be greater than or equal to 83. Okay, and it'll, in order to maintain a B, be less than or equal to 86. Now, the question is, how do you find your average? How do you find an average? Yeah, you add them all up and divide by the number of numbers you've got. Average. Abbreviation for average. Okay? Sorry. Okay? Not a terrible question. Just abbreviation for average. All right? How do you find the average? You add up all the numbers, divide by the number of numbers. How many numbers are you going to have in the end?
4.
Yeah, fourth and final test, right? So your average is going to be taking 79 plus 88 plus 82, which are your 3 tests, plus, what's the 4th test score?
X.
Right, you don't know what it is. So let it be X. And so we need to define X as the 4th test score. That's an 88, yes. Don't be a hater. Okay? And since there's 4 numbers, we're going to divide all that by 4. And that's your average. Okay? And that has to be less than or equal to 86. That looks complicated, but we can actually combine some like terms, right? In other words, we can add 79, 88, and 82 to get 170 plus 79, which is what, 249? Ends up being 83 is less than or equal to 249 plus X all over 4, less than or equal to 86. Now we're setting up just like the practice problems you guys had a few minutes ago. Right? Multiply through by what?
4.
Yeah, multiply through by 4. Multiply everything by 4 so we can get rid of that fraction. These 4s are going to divide out. I'd go ahead and divide them out. Go ahead and cross them out so you don't have to worry about them anymore. Okay? 4 times 83 should be 332?
Yeah.
Is that it? Thank you. And then 4 times 86, 344. Is that right? Okay. And then we subtract 249. And so what you discover by doing this is that your score on the 4th test, which is what X represents, would have to be between, 83 and 95 inclusive. So you can score anywhere from an 83 to a 95 and still maintain your B. Okay? Now we have a number line here, so we might as well graph this. 83, 95. Inclusive means that you can score those and be good. And there's in between. Okay? So the only tricky part here is remembering how to find an average and putting it in from there. I think. Maybe not. Okay? Questions on that guy? Every story problem is a little different. Just got to make sure you look at them and think it through. Okay? All right, number 13 says, to qualify for the child rate at Holiday World, a person's age must be greater than 2 and less than 12. How would you write that? Right? Your age would have to be greater than 2 and less than 12. So between 2 and 12, basically, right? So 2 is here, 12 is here, open circle, because it's not equal to, and bam, there's your graph. And last but not least, water is non-liquid when the temperature is 32 degrees or below, or as it is at least 212 degrees Fahrenheit. Right? The word or is in there. So it's non-liquid when the temperature, let X be the temperature, is less than 32 or equal to, because it's 32 or below, or as at least 212. So greater than or equal to 212. Right? Since they can be 32 and 212, we're going to close those circles. We want x is less than 32 or x is greater than 212. There's your oars on a boat. Okay? And that's it.